This is Professor Peld, and this is Algebra 2, Chapter 5, Section 2. This is Part 4. So now we want to simplify, but we want to simplify radicals that have both variables and constants, and doing adding and subtracting. So we're going to use all the rules again, but now kind of combining everything together. Okay, so the third root of 64, so I can break that down. Oops, let me turn the marker on here. So this is the third root. Let's see, 64 is 8 times 8, so that's 2, 2, 2, 2, 2, 2. And y to the sixth is y to the third, y to the third. So typically you don't want to write out all the things in this case because it becomes very, very long. So if you have like y to the 100th, you don't want to write 100 y's. So this is 2 to the third, 2 to the third, y to the third, y to the third. Okay, so each one of these is a group of 3, which comes out. So that comes out, that comes out, that comes out, that comes out, leaves me 2 times y times y for a final answer of 4y squared. Because essentially, if you do each one of these individually, that's what you have, right? Or third root of y to the third. Either way, it's going to cancel, leave you 2's and 3's. So making them in groups of 3's or whatever the index is the easier method to do. So 5 or fifth root of 4, which is 2 to the second. There's no groups of 5 there. Don't need to worry about it. But A is A5 and A3. I can make a 5 there. That's 8. And 14 is B5, B5, B4, and C5. So the way I broke it up is as many groups of 5 as I could possibly do, where it still adds up to the original number because of the product rule. Okay, so a group of 5 comes out, a group of 5 comes out, a group of 5 comes out, a group of 5 comes out because it's index of 5. So that's A, B, B, C came out, and I'm left with inside 4A3B4 for a final answer of AB squared C, which really does the first power if you want to put that, times the fifth root of 4A cubed B4. So this satisfies the first rule of simplification with radicals, is that there's nothing left inside for groups of 5 other than products of 1. So it's fine. We don't have to worry about the fraction part here because there are none. Okay, next one, adding and subtracting. There's only one rule for adding and subtracting for all of math. It's like terms. Are they like terms? Are these like terms? No. However, we can break this down. 12 third roots of 2z to the third and z second gives me 5 minus z third roots of 54, which we'll do in a second. Actually, we'll do it up here. 54. If you think about what 54 is, that's 2 times 27, which is 2, 3, 3, 3, correct? So that's 2 times 3 to the third, and we have a z to the second. So we have a 3 that can come out here, and a z that can come out here. So that's 12z third roots of 2z squared left over, minus a 3 comes out, 3z third roots of z squared. 2z squared. I'm sorry. I forgot the 2 there. 2z squared. Now, if you look, they're actually like terms. So 12 minus 3 gives me 9z third roots times the third roots of 2z squared is our final answer. Okay, let's go down and do the next 3. Okay, so we have the quotient rule of radicals. So we can break this apart. So we get the fourth root of x to the fourth over the fourth root of y to the eighth, which is y4 and y4. So I have one group here and two groups here, and there's nothing left out inside. So I'm left with x over y squared is our final answer. All right, next one is a problem because 8 does not break up into groups of 3, and we're failing the third rule, which is you cannot have radicals in the denominator. So I need more y's. How many more y's do I need? I need one more y to make 9, which is the first factor of 3. So I have x third roots of y. And now that I have 9 on the bottom, that gives me y3, 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 using the product rule. So I get x third roots of y over y times y times y that come out. So x third roots of y over y cubed. Okay, next one, quotient rule of exponents. If there's nothing there, you can put a 1. So I really have 12 divided by 2, which is 7, x to the 1 minus 3/4, and then y to the 1/3. Well, there's no y in the bottom, so I can put a y0 there, right? So it's 1/3 minus 0. And then z, I don't have any z's in the top, so I can put a z0 as a placeholder. So it's 0 minus -6. Because remember, the quotient rule of exponents is subtract. So 7x, so 1 minus 3/4 is 1/4, times y to the 1/3 times z to the 6th. Okay. All right, pause the video, try the student problems for yourself. Okay, so 27 is 3 times 3 times 3, or 3 to the third, and that's x3, x3, x3 for x to the 9th. So we get all groups of 3, so 3x, x, x. So that is a perfect radical because nothing's left over. So 3x to the third power is our solution. Next one, fourth root. Let's think about it here a second. 32 is, let's see, 1, 2, 3, 4, 5, I think. Let me just think here for a second. That little extra thing there. That's 2, 4, 8, 16, 32. So that's 5 of them. So we have 2 to the 4th and 2 to the 1 for the 32. And we have A4, A4, and A1 to get groups of 4 for the 9 A's. And then we have B4, 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 and B4 for B16. And then C4, C4 is C8 and 3 more makes 11. So that is our total breakdown. So we have a 2 that comes out, 2 A's that come out, 4 B's that come out, and 2 C's. And we're left with a 2AC cubed. Okay, so we can simplify farther. So 2a squared, b to the 4th, c to the 2nd, times the 4th root of 2ac cubed. Okay, so that satisfies rule 1 where you can only have a product of 1 left over inside. All right, c, are these like terms? They are not. This is square root by default, right? There's no index shown. So that is the square root of 3 squared w squared w squared w, right? You know, let's move that down a little bit, actually. Leave myself enough room. Okay, so that's the square root of 3 squared, which is 9, w squared, w1 for 5 w's, and then w squared times w1 is w3 in the second one. So if a 3, a w, and a w comes out, left with square root of w, minus a w comes out, so that's w square root of w. So you have 3w squared square root of w minus w squared square root of w. So I really have, if you think about it, 3 minus 1. So I really have 2w squared square roots of w. Okay, let's scroll down to the last 3. Okay, quotient rule. Are these groups of 5? Yes, they are. So I have the 5th root of x5 and x5. I can break it up into 2, top and bottom, using the quotient rule of radicals. Group, group, group. So I have x over y, or x squared over y1. So next one, this fails the third rule, which you can have radicals in the denominator. I have 10. I need the next factor of 4, which is 12. So I need 2 more y's to make this work. So that's x 4th roots of y squared over, now I do have 12. That's y4 and y4 for a total of 12. So I have 3 of these. So x fourth roots of y squared over y to the third power. All right, next one. 6 divided by 3 is 2. That's a 1, so that's x to the 1 minus a half. And 3/4 minus 1/2. So we're using the quotient rule of exponents. So that's 2x to the 1/2, 1 minus a half, and 3/4 minus a half is y to the 1/4. There's our final answer. And again, these can be written whenever there's fractions in 2 different ways. So this could also be 2 times the square root of x times the fourth root of y. Either of those is the equivalent answer. One's just exponent form, one is radical form. That is the end of this lesson.